In the last section, we worked on our print options method, and we finally tested it out at the terminal. Now, it definitely worked correctly, but I want to come back to this thing, and I want to mention one little problem with the method as we've currently put it together. So inside this method, we iterated through our list of options by using a manual for loop right here. In general, when we are writing Dart code, we want to at least try to not use manual for loops as much as possible, just because it's really easy to make a tiny little error in writing this thing out right here. So for example, I could have accidentally written something like, I don't know, I greater than options.length, or who knows, maybe I could have missed a semicolon. There's just a lot of characters in here that are very easy to mistype. So since Dart wants to generally steer us away from using manual for loops like this, they implement a ton of helper methods in the standard library to assist us in iterating over collections of records, specifically to help us iterate over lists. Let's very quickly go check out the documentation for our list class one more time. I know we've looked at that documentation quite a bit, but we're going to go look at it one more time, and we're going to try to find a method that's going to help us iterate over our list of options a little bit more easily than writing out a full for loop like this right here. So I'm going to pull up my documentation for the list class. Here it is. I'll then scroll down to the very bottom, and then I'll scroll up just a little bit. So inside the section with all the italicized text right here, you'll notice that there's one method called for each right here. So this for each method behaves very similar to how for each works in many other languages out there right now. We can use for each to iterate over a list of records. We pass a function into for each, and that function will be called with every element within the list. So that's a perfect use case for what we are trying to do right now. There's just one little holdup, one little issue. I want you to take a look at this function signature right here very carefully, and then think about the demands or kind of the requirements of our iteration step right here. So our iteration step, for every element in that list, we are going to print out not only the options label, but we also print out that options index in the list. Printing out the options index in the list right here is extremely important because it tells our users what individual number they need to actually write out to select a given element, right? So we were just printing out the index like it was 0 or 1, and so if a user wanted to select red right here, they would have to enter 0. So printing out the index of the element in the list is extremely important for our application. Now with that in mind, if we go back over to the list documentation, you'll notice that the function signature right here for the for each function says that we can call for each and pass in a function, that's what this F thing right here is, and that function will be called with each element in the list, but it's not called with the index of that element. When we use for each right here, we are not told what the index of the element is within our list. And so that makes for each right here not appropriate for what we are trying to do, because a very hard requirement for our iteration step right here is to print out the index of the element in the list. So even though we cannot make use of that for each helper, there's still a little workaround that we can use. So it turns out that iterating through a list of records and knowing the index of each record is something that we really need to do quite frequently inside of a lot of code that we write. And so many developers out there feel that this kind of for each right here that does not provide an index is not the best implementation of a for each helper in the world. So as kind of a official workaround for the fact that for each does not give us an index, we're going to instead use a slightly different data structure to iterate through all of our different options and then print something out to the terminal. So let's take a quick pause right here. We're going to come back in the next section and we're going to talk about a slightly different data structure that's going to allow us to avoid having to write out a manual for loop like this right here, but still get access to the index of every element as we iterate through that list of options. So quick break and I'll see you in just a minute. In the last section, we spoke about how this for loop right here is not really ideal Dart code. Ideally, we would be able to write out some iteration helper to assist us in getting through every element inside of our options list. But as we mentioned, the built-in for each helper does not give us access to each index or the index of each element in the list, which is a hard requirement of the code that we're going to use. So in this section, we're going to talk about how we're going to get around that restriction. So to solve this, we're going to use a function called asMap. So I want you to imagine right here that we are working with our list of options. So this is currently what we have inside that print options function. We're going to take that list and we're going to call a method on it called asMap. When we call asMap, it takes our list right here and it returns an entirely new data structure, a data structure that we refer to as a map. A map is very similar, almost identical to an object in JavaScript or a hash in Ruby. So if you're familiar with JavaScript or Ruby, or how about, let's say, PHP, it's similar to an associative array. So many other languages out there have analogs to a map. A map is a collection of key value pairs. So on the left-hand side, we've got a key, and it refers to some value inside that map. When we call asMap on a list, we get back a map data structure where the keys are the index of each element inside that list, and then the value is the actual element that existed at that index. So we can kind of imagine right here that if this was option 0, and this was option 1 and option 2, option 0, which is at index 0, gets assigned to the value 0 right here, and so that would be option 0, and we'd have option 1 and option 2. Now once we build out this map right here, or at least once we call asMap and get access to this map, we can then make use of a iteration helper on the map class that's going to satisfy our requirement of knowing both the actual option and the index of that option as well. So that's why we're going to use the map. Map has a iteration helper that satisfies our requirements. Now before we just dive into writing the code here for print options, I want to tell you a little bit more about maps because they are a pretty important data structure that we're going to eventually use over inside of some Flutter applications in the future as well. So we're going to do just a very brief detour here, and I'm just going to give you a little bit of code to play around with over on Dartpad. So if you want to, you could pop open Dartpad inside of your browser again. You'll notice that I've declared a void main function inside of here. And inside of the main function, I'm going to declare a new map. So we're going to pretend that we're going to make an English to Spanish dictionary out of a map object. So I'm going to declare a new variable called English to Spanish, and I'm going to assign a map to this. To create a new map, we can write out a set of curly braces, and then inside of here, we put together a collection of key value pairs. So let's say that I want to convert the English word for red to Spanish. The Spanish equivalent of red is rojo, and then we can repeat this process down, like say for blue, which is azul, and green, which is verde, like so. One thing that you'll notice here is that on the very last key value pair, I've placed a semicolon, or excuse me, a comma. This comma on the very last key value pair is optional, so you don't have to put it in if you don't want to, but I will tell you that later on, once we start working with Flutter, putting on a comma on the very last key value pair is something that starts to get a little bit critical when it comes to formatting our code. So it's kind of a good habit to get into right now, to make sure that you put a comma on the very last key value pair inside of a map. So now that we've defined a map, we can easily reference the keys and the values stored inside of here. So I could say print, I could reference the map that we just created, English to Spanish, and then to access a value inside of here, I can place a set of square braces and then enter in as a string any key that has been defined inside that map. So if I want to convert, say, red over to the Spanish equivalent, I will put the key of red inside of here. And now if I run this code, I will see rojo appear on the top right-hand side. There we go. Now, one big difference between JavaScript objects and Dart maps is the way in which we access properties. So to access a property in the map, we use this square brace syntax that you see right here. In JavaScript, so if you're used to writing JavaScript, you might be used to doing something like English to Spanish .red, like so. So this is not a valid way of accessing properties within a map. We cannot use the Dart syntax. They are not like objects in that regard. So we have to use the square brackets to access any property defined within the map. Now the last thing that I want to mention is the way in which we define maps. So you'll notice that in this case, I did the variable declaration of English to Spanish and the initialization all in one expression, all on one line, essentially. But it's very common to write code that might look a little bit different. Maybe something like this. Maybe we only define the variable up here and we just initialize an empty map, and then maybe we would write out some code to fill in values on that map. So maybe we would then later on say something like English to Spanish at red equals rojo. So this is kind of a common structure in code that you might see, who knows, for whatever reason. Maybe you don't really know ahead of time what different values or keys that you want to add to this map right here. So you might first initialize the map completely empty, and then later on start to add some keys. Now, this is totally fine to take this type of approach right here. There's just one quick thing I want to mention to you. As a quick reminder, Dart does its best to figure out the type of every different value that we make use of inside the language, right? So whenever we create a new value, Dart is going to try to figure out the type for us. But in this case, if you click on English to Spanish right here on the top line, you'll notice that at the bottom right-hand side it says map, dynamic, dynamic. So in this case, we have not given Dart enough information to figure out what the types of the keys and the values are inside that map, even though we added in some strings later on down here. So in order for Dart to have enough information about the types of values that are going to be stored inside this map, we would have to annotate the map itself and tell Dart, hey, here's the types of values that I expect to be inside of here. Otherwise, it's just going to default to saying dynamic, dynamic, which means we can toss anything inside of here that we want. Now, of course, we can totally leave it like this. We can go without defining strict types here, but in general, I do recommend trying to make use of the type system where possible. So if we wanted to solve this issue, we could specifically annotate the type of values that are going to be stored inside this map. To do so, right in front of the curly braces, I will put a less than sign. I'll write out string, comma, string, and then a greater than sign, like so. So this is a type annotation for the map that we are creating right after it. This means to say that all the keys inside that map are going to be of type string, and all the values are going to be of type string as well. So now if I click on English to Spanish again, you'll notice that the map is properly annotated as containing keys of type string and values of type string. If I tried changing the key type right here from string to say int, well then later on when I tried to put the key of red inside that map, you'll notice that I get this nasty error message saying that I can't use a string because the keys inside of English to Spanish are supposed to be integers instead. So again, this is strictly, it's an optional step, but in general, I do recommend trying to annotate types on your variables as much as possible. Okay, so now one very quick last thing. We've kind of done a big detour here into the world of maps. So let me just, we're going to close this out pretty quickly. Oops, I got that one backwards. So I'm going to go, there we go, blue, azul, like so. So the entire idea behind using a map right here was to be able to iterate over all the elements inside of a list and get not only the values of that list, but also the indices as well. So one of the methods that's included on every map instance is a for each helper. Now the for each helper that's available on a map works slightly different than the one that's available on a list. So again, here's the list documentation. When we call for each, we get each element, but not the index of the element. So if we go over on the left-hand side and pull up class map right here, we can look up the documentation for the map class. And on here, if I scroll down on the right-hand side a little bit, under methods, I'll find for each. And so as you might guess, if we call for each on a map, we get to pass in a function that gets called with the keys and the values of every single entry in that map. So that's why we're using a map here. We can call for each on a map, which has a slightly different function signature. So as a quick example, back over inside of Dartpad here, I can call English to Spanish dot for each. You'll notice the function signature right here says that it gets called with the string, which is the key, and the string, which is the value of every key value pair. So then I'll pass in a function. And this will be called with the English color and the Spanish color. And now I can print out something like, how about English color is Spanish color in Spanish. And I'll zoom out just so you can see that entire line. So by using a map, when we use for each, we get access to all the keys and all the values inside of every key value pair. So now if we run this, any second now, there we go. We'll see red is rojo in Spanish, blue is azul in Spanish. All right, so this has been a pretty big detour here. I apologize for the length of this section in particular, but now that we've got a better idea of how maps work, we can go back over to our print options code. We're going to take our options list right here. We're going to turn it into a map, and then we're going to call for each on it, which is going to allow us to iterate over every value or every option in the list and its index as well. And it will allow us to clean up our for loop right here. So let's take a quick pause right here, and we'll continue in the next section. In the last section, we had a long discussion about maps in Dart. So we're going to flip back over to our print options method right here, and we're going to do a little refactor around this for loop right here. I'm going to first get started by commenting out the for loop that we had written. Using VS Code, I can automatically comment out stuff by hitting Command / or Control / if you're on Windows. And then underneath that for loop, we're going to make sure that we iterate over this list of options. We're going to first turn options into a map and then use the for each helper on that map. So I'm going to say options.asMap. So when we call asMap, it's going to take that list and it's going to turn it into a map automatically. So we now have a data structure that looks like this right here. So all the keys inside that map are indices, and all the values are the original options that we had been working with. So now on this map, we can call for each, and we'll pass in a function that's going to be called first off with the index of every element, and then as the value, we're going to get our option. Then inside of here, we're going to do that same standard out write line that we did before. So I will do standard out dot write ln, and then we're going to print square braces. Inside there, we'll reference our index, so $index. I'll do my dash, and then this time we do not have to do options bracket I like we did before. We only did options bracket I before so that we could look up the appropriate option in our options list. But this time with for each, we've already been past the option that we are iterating over at this current point in time. So we can just write out $. We're still going to use the curly braces because we're going to do a little bit of a value lookup on this thing, or we're going to write out an expression rather than referencing a simple variable. And then inside of here, we can do option.label, like so. And that grabs the string that belongs to that option object. I'll make sure I get a semicolon at the very end of the line. Okay, I'll now remove the commented out stuff that we have right here. I'm going to save this file, and then we're going to flip back over to the terminal and test this out again. So back at the terminal, I'm going to make sure I'm still inside my example directory, and I'll do my dart main.dart. Awesome. So we see the same exact thing that we saw before. So we get the square brackets, a 0, and if I wanted to select red now, I would hit 0 and hit enter like so. Okay, so again, doing this refactor right here, it was optional. We could have stuck with the for loop if we wanted to. But in general, we try to avoid for loops because they are so prone to making tiny typos, and we might accidentally break something, you never know. Now, the other thing I want to mention here is that if we were not caring about the index at all, we would have not had to use a map. So if we did not care about the index, we could have left options as a list and just said, okay, we'll call for each on that list and we'll be happy. But because we did care about the index of each option, that's the sole reason that we first converted this thing to be a map. That's the only reason. If we didn't care about the index, we would have not done that conversion. Okay, so we're all done with this refactor, and we now have a better idea of how maps work. So let's continue in the next section. We've now got our terminal and option classes in a pretty good spot, which means that we're ready to move on to our prompter class. So remember, the prompter is kind of like the main interface for our entire library. It's the thing that's going to take some string prompt, like the actual question that we want to ask, this thing up here. It's also going to take the list of options, and then it's going to facilitate the process of using our terminal class to actually print this stuff out to the terminal and get the user to enter some response. So let's figure out what different methods and fields we might want to put on that prompter class. Well, honestly, very much like our previous terminal class up here, I'm not entirely sure that the prompter really has any data associated with it whatsoever. I'm not really having an easy time thinking about the different fields that we might place on here. Now, maybe we will eventually, but at least at the very outset right now, I can't really think of any data that I would want to tie to the prompter. For methods, however, well, I think we'll definitely end up with at least one method. I think that we'll add on a single method right now called, how about ask, like the word ask. So maybe we'll have a single method called ask, and we can call this method with a prompt, kind of like the string to put right here, the question itself, and we can also call it with a list of options, and those options are going to be what gets printed out to the terminal. Then if a user selects something right here, or whatever number they put in, we could then have the ask method return the option that the user selected. Now that's kind of a little bit down the road. For right now, all we really need to understand is that we'll have the ask method and we'll call it with a question we want to ask and a list of options. Now, one thing that I'm going to tell you right now is that we're going to do a little bit of a progressive refactor on this prompter class. So we're going to start off with a very simplistic single method right here, and then over time we're going to kind of point out a couple of weird things about the ask method, and we'll come back and we'll start to refactor this class a little bit. So this is not going to be the final implementation, it's just going to be our first take on it. So with that in mind, I'm going to flip back over to my code editor, and I'm going to open up my prompter class. So inside of prompter, I'm going to open up the class body, and I'm going to define that ask method. So like we just said, I think that ask is going to get called with the string representing the question that's going to say like, hey, select a color, or what's your favorite ice cream, or whatever it's supposed to be. So I will mark that as an argument of type string, and I will call it the prompt. It's essentially what we're asking our user, or what gets printed out to the terminal at the very top. Then as a second argument, we'll say that we will receive a list of all the different options that should be printed at the terminal. So it's going to be a list that contains options. Notice that we just write out the word option here. It's not plural. We don't write options. It's just option like so. And we will refer to it as options. Now right away, you'll notice that we got the red squiggly right here because we have not imported the option file into the prompter. So right now the prompter class, or this prompter.dart file, has no idea what an option is. So we need to make sure that we import the option.dart file. So to handle that, remember we are in that easy situation here, thank goodness. So we're in the second situation right here. We are trying to import something from the lib directory into another file in the lib directory. So all we have to do is write out the name of the file that we want to import. So at the very top, I'll write import option.dart. And now that error goes away. Okay, so that's a good start. Let's take a quick pause right here. We'll come back to the next section and start implementing this ask method. In the last section, we started working on our ask method. We're now going to take that prompt and the list of options right here that we received as arguments and use our terminal class to print these out to the terminal. So the code that we're about to write right here, we've kind of already written once before inside of our example main.dart file. So back over here, we had created our list of options, and then we used the terminal to print all those options out. So we've kind of already gone through this process once already, so the code that we're going to write here will not be terribly scary, I think. So inside the ask method, we first need to get access to our terminal class so we can use it to print out the prompt and the list of options. So to get access to the terminal, we'll make sure that we first import it at the top. And then inside of ask, we'll create a new instance of that terminal. So I'll say var terminal equals new terminal. Then we can use this terminal instance to print a prompt and to print the options. So we'll say terminal.print prompt, and we'll pass the prompt in, and terminal.print options, and we'll pass the list of options in. Okay, so that's not too bad. Let's do a quick test of this right here and just make sure that we are doing okay. And then when we make sure that this code actually works, I want to point out something that's a little bit funky about this line of code right here. But we'll do a quick test first, then we'll talk about, maybe a possible way to improve this line. So to test this out, we'll go back to our main.dart file. Inside of main.dart, I'm going to do a little bit of cleanup. So we no longer need to create an instance of the terminal inside this file anymore because the prompter is going to take care of that for us. When I delete that line of code, you'll notice that our terminal.dart import up here gets a green squiggly, so it's no longer in use, which means we can delete it. And then I will also clean up some of the code down here as well. So all we're going to be left with is the option import and where we declare our list of options. Now we can import the terminal file. So I'll do import package, my package name, src directory, terminal.dart. And then down here, we'll call, I called it terminal, my mistake. We don't want the terminal, we want the prompter. So then down here, we can create a new instance of our prompter. So I'll say var prompter equals new prompter. And then we can call prompter.ask. As the first argument, we'll provide our prompt. So I'll say something like, what color do you want? And then as a second argument, we'll pass in our list of options. Okay, so that looks pretty good. Let's save right here, and we'll do a quick test just to make sure we're going down the right path. So if I go back over to my terminal, I can run dart main.dart, and I still see asked right here, what color do you want? And we get our selection. Now at present, we are not asking the terminal to watch for any input from our user. And so just like way before, our program immediately exits back to the command line. So I think that inside of our prompter.dart file, after we print out our prompt and our options, we probably want to do something right here and make sure that we tell the terminal to watch for some input from the user. But like I said, before we do that, I want to point out something a little bit interesting about this line of code right here. So let's take a quick pause, and we're going to come back, talk about this line of code, and also make sure that our terminal starts watching for input from the user. In the last section, I mentioned that this line of code right here inside of our prompter class was a little bit strange. So in this section, we're going to expand upon that, and we're going to do a brief detour and talk about an additional topic in Dart that's going to be pretty important once we move over to the world of Flutter. So I want to very quickly look at a diagram of what happens when we create a new instance of prompter and then call this ask method right here. Okay, so here's kind of a timeline diagram of what happens when we make use of that prompter class. Inside of our main example file right now, we create an instance of the prompter. We then call prompter.ask, and when we run that method, we create a new instance of the terminal. And now here's where things get interesting. Inside that ask method, we make use of that instance of the terminal by calling the print prompt and the print options methods. And then right now, we exit or we return from the ask method, and the terminal does not get used again. So we essentially throw away that terminal. Now the reason that this is kind of concerning is that every single time that we call that ask method, we are creating a new instance of the terminal right here. So every time we call ask, we create a new instance of the terminal, and then as soon as we leave this method, we throw it away. So we are definitely doing more work inside this method than we need to do. We could very easily extract this declaration right here and put it basically anywhere else inside the file and reuse the same terminal over and over again. So that's why I refer to this line of code right here as being a little bit strange. We simply are doing more work than we have to whenever we call ask. So in the last couple of applications that we've worked on, we've seen good examples of adding instance properties to classes. In other words, maybe we could go over to our option.dart file right here. We've seen examples of how we can create a field or a property on a class, assign it some type, and then initialize that value at some point in time. And so that might be one thing that we could possibly do here. we could possibly decide inside of our prompter.dart class to make a new property on our prompter class. So maybe we will call this new property something like terminal. We'll define it as being of type terminal. And then anytime we create a new instance of prompter, we'll make a new terminal, like so. Now we can clean up the declaration inside of our ask method, and we don't have to make use of that anymore. So now the instant that we create a new instance of the prompter, we automatically get a terminal created, and we can reuse the same terminal every single time that we call ask. But there's just one other thing that I want to point out here. One other thing. When you start looking at the terminal class and start thinking about our implementation of it, let's open up that file very quickly. You'll notice that inside this terminal class right here, we have no fields assigned to the terminal. The terminal really has no, you might say, state tied to it. In other words, we can't really modify the terminal in any way, shape, or form in any way that's kind of meaningful. So even by assigning a terminal to a field on the prompter class, if we end up creating multiple instances of prompter, we will be creating multiple separate instances of the terminal. And what I'm trying to say here is that we really don't need multiple instances of the terminal. So even making this a field on the prompter class is kind of overkill, and I think that we don't have to create a separate terminal every single time. So rather than recreating this terminal every single time we create a prompter, I think that we should maybe pull this thing up one level farther. So maybe we should move the terminal declaration outside of even the prompter class declaration. So outside the class, I'll add in terminal is a new terminal. And now anytime we call the ask method right here, we're going to attempt to reuse that same terminal. And if we make multiple instances of prompter, we're always going to be using the same terminal, and only one is going to be created inside of our application. Okay, so this approach right here, it definitely works. It's not the worst thing in the world. But there's a couple of additional considerations that I want to point out. So let's take a quick pause. We'll come back to the next section, and we'll point out a couple of additional interesting items about this right here. In the last section, we extracted our terminal definition to be outside of the prompter class. So now when someone makes use of our library, there will be exactly one instance of terminal created at any point in time. So even if we make multiple instances of prompter, they're all going to be sharing the same terminal. Now, by putting this definition up here, we're kind of exposing ourselves to another possible issue in the future. So let me tell you about what that issue might be. Let's imagine that you and I put together this prompter.dart file right here, and we say, you know what, this code right here, it looks great. We're going to save this and we're going to deploy it to the world. And then maybe at some point in time, like 3 years in the future, so sometime very far in the future, maybe another engineer comes to this file and they say, you know what, we've got this terminal class right here and the terminal's great, but it would sure be awesome if we had some function tied to our prompter class or some method tied to it that could like swap out the terminal we're using for a different one. So maybe some engineer at some point in the future comes into this file and they say, you know, I would love to change that terminal. So maybe they're going to add on a change terminal method and they'll pass in some variable that they will call new terminal. So who knows what this thing is? Maybe it's a new instance of the terminal class. I don't know. Let's just imagine for a second that it's some brand new terminal that they decided to implement inside of our library. So then inside of this method, chances are they're going to put together some code that looks like this, something that says terminal equals new terminal. So now they walk away thinking that they just did a great job, and they think that they have expanded this prompter class right here to have kind of a terminal that can be swapped out on the fly for a new terminal that does maybe some slightly different behavior. I don't know, who knows what it does. But I want you to think about what is going to happen with this new method right here. Now, if anyone calls change terminal right here, and they assign a new terminal to the terminal value, that means that every single instance of the prompter class that exists is now going to be making use of this new terminal. Because by saying terminal equals new terminal, we're essentially taking this new thing right here, or whatever got passed in, and we're saying this variable up here, hey, you just changed. You are now new terminal. So by extracting this variable declaration to outside the class, we've kind of now exposed this possible bug in the far future. And hey, you're probably looking at this thinking, Stephen, who in the world would do this? But I just want you to imagine, well, who knows? Maybe this is the case at some point in the future. I really don't know. So to prevent this happening, there's actually a very straightforward way that we can kind of lock down this terminal variable right here. So you'll notice that everywhere inside this course so far, we've been declaring variables by using the var keyword. So like inside of main.dart, here's var right here, here's var right here, and we've used it in just about every other application we've put together. That var keyword is just one way of many of declaring a new variable. One other possible way of creating a new variable or declaring a variable is by using the keyword final. So to solve this whole issue right here of having a change terminal method and accidentally overwriting the terminal that's being used by every instance of prompt that there is, we could put the keyword final in front of our terminal definition. The final keyword right here means that we are going to declare a new variable that can only get assigned a value exactly one time. And that one time is occurring right here. So when we use this final keyword, we're saying, hey, you know what? We're making a new variable called terminal. We can only assign a value to it exactly one time. And we just used up that one time right here. So now if we go down to this terminal assignment down here and hover over it, you'll notice that we get a message that says terminal is a final variable and it can only be assigned or initialized or given a value exactly one time. And so just by adding on this final keyword right here, we've made sure that someone in the far future who does not really understand our code will not have the ability to easily swap out the value of terminal. They're going to see, or maybe they would put this method together right here, they would see that error message and it's kind of a signal to them that, oh, okay, I'm not supposed to reassign the value of terminal here. So the purpose of final is really kind of, well, you understand the purpose, I'm sure, because I've repeated it like 3 times now. When we use final, it means that we can't reassign the variable, but its effective purpose, like what it really does inside of our code, is kind of twofold. On the one hand, it prevents people from accidentally reassigning a variable. And second, and this is possibly the more important focus or the more important purpose of it, by placing the final keyword right here, we are informing other engineers in the future, or maybe even you and I, the people who wrote the code at some point in the future, that this variable right here is not intended to be reassigned. So final not only is going to keep you from reassigning the value assigned to that variable, it also is a signal to other engineers that you don't want them to mess around with that variable and try to reassign it. So in practice, in the vast majority of Dart code we write, we end up using this final keyword because it turns out that a lot of the variables that you and I are going to create in real Dart applications don't always need to be really reassigned at any point. You'll even notice that inside of our main.dart file over here, we create this options variable, and we also create prompter right here. So I want you to think for just a second, what's the chances of us having a really good reason to declare the options variable right here, and then should try to reassign it later on with like a new set of options? Well, personally, I don't actually write code like this very often. I don't know about you, but it's actually kind of uncommon for us to reuse variables inside of one function or inside of one file. Usually we just have one variable, it gets used for one purpose, maybe we modify the value of that variable, but we never really reassign it a totally new value that often. So in practice, in a lot of Dart code, you're going to see that we end up using the keyword final all over the place, rather than the keyword var to declare new variables. Okay, so in this section, we started talking about the existence of the keyword final. Now there's a couple more things I want you to understand about final, and in addition, there's even a couple of other ways of declaring variables. So let's take a quick pause. We're going to come back to the next section, and we're going to talk just a little bit more about declaring variables. In the last section, we started talking about the use of the final keyword to declare new variables. Just to be clear, we can sometimes make use of the final keyword in place of the var keyword. In this section, we're going to expand on the final keyword a little bit more and talk about one additional way in which we can declare new variables. Before we get started, I'm going to clean up this change terminal method down here because we definitely don't want that hanging around and I don't want to risk leaving it in place. But I will leave this declaration up here because we are going to actually come back in just a little bit and change it up as well. Okay, so now I'm going to flip over to a diagram that's going to help us understand the very clear difference between var and final, and also introduce one additional way of declaring variables. So in this course so far, we've been making use of the var keyword to declare variables. We use var anytime that we want to create a variable that we can reassign a new value to at some point in the future. If we expect to never have to reassign this variable, we will instead use the final keyword. Now you'll notice down here I've added on one additional keyword for declaring variables called const. So const is kind of nasty. We're going to look at an example in just a second, but before we do, I want to clarify just one final difference between var and final. So you'll remember that way long ago, like back in the first section of this course, we looked at that diagram that clarified the difference between a variable, like a reference, and a value. So a variable has the ability to point at a value inside of our application. A value exists inside of memory completely decoupled from variables. So variables and values, completely different things. So that starts to get very important once we need to understand the difference, or the true difference, between var and final right here. So I want to flip over to Dartpad again, and we're going to write out just a tiny bit of code to really illustrate the differences between var and final. So I'm back over at Dartpad. Remember, you can get here inside your browser by going to dartpad.dartlang.org. Now I've already defined a main function, and inside of here, I'm going to declare another map, like the one that we looked at a couple of videos ago for translating from Spanish to English. So I'm going to make a new variable called translator, and I'm just going to make a raw map, or a map literal. So I'll write out red is rojo, and blue is azul. So again, kind of thinking about making a English to Spanish color translator of sorts. So you'll notice that I created this map with the var keyword right here. So as we've said in the last section, and now this one several times, when we make use of the keyword var, that means that we can reassign this variable at some point in the future. So down right here, I could say translator is now instead, how about let's replace it with a translator for English to German colors. So red in German is rot, and blue in German is blau, or I'm sure there's a better pronunciation, but you get the idea. So in this example right here, you'll notice I've got the little warning saying that, hey, I'm not using this variable, but clearly Dart is not complaining. Dart has no issue with the fact that I took one variable right here and assigned a completely new value to it down here. So this is behavior as expected with the var keyword. I can freely reassign this variable. Now we're going to replace this with final, and the instant I do, you're going to notice that we start to get an error message down here. So now that I've marked translator as being final, we now see an error message that says, hey, you can't reassign the value of translator. You can't change it. Okay, so clearly this is probably expected. Like I've now said this 5 times in the last 10 minutes. You understand when we use final, we cannot reassign the variable. But here's where that idea of variables versus values starts to get really interesting. So I want you to see something here, something that might be surprising. I'm going to say translator, and I'm going to add a new property to this map right here. So I'm going to add on a key of green, and I'm going to give it a value of verde, which is Spanish for green. And you'll notice that now Dart is not complaining. So the keyword final right here is only modifying the variable translator. That's all it modifies. It says this variable translator cannot be reassigned. The final keyword right here has absolutely zero effect on the actual value that we assign to that variable. So you might think that final means, hey, this is the final value and it can never change. That's not true. We can still change the value right here. We just cannot directly change what the translator references. Remember, this is a variable. It references a value that is stored in memory. We can change the value. We just can't store what the variable points at. That's the limitation. Okay, so that is a very important distinction to make between var and final. Final is just about saying, hey, you know what? I'm not going to ever try to reassign this variable again in the future, but we can still modify the underlying value. It does not lock down anything. All right, so I think that's more clear now. Now, as I said in this diagram right here, there is this other third way of declaring variables besides just var and final. So the third way is const. Now const, yeah, it's nasty. It's a little confusing, but it's definitely a very important part of Dart because, again, this is a keyword right here that we're going to make use of a tremendous amount once we start writing Flutter code. So let's take a pause right here. We're going to come back to the next section and start talking about what const does. In the last section, we spoke about some of the big differences between var and final. We're now going to move on to introducing const as well. So in this diagram, I had marked const as being kind of a little bit trickier subject to understand. So let me first begin by telling you why const is a little bit more tricky than var and final are. Var and final are used to declare variables. We've seen that many times throughout all of our applications. We've used this var keyword to define a new variable. And as we just learned, final is used for the same thing. So the reason that const is a little bit tricky is that const not only is used to declare variables, but it also has another function in Dart programs beyond that as well. So const is similar to var and final, but it also has added functionality on top of that. So let's take a look at a diagram that's going to clarify exactly what that added functionality is. Okay, so this is a very similar diagram, but I've expanded const into two separate rows. So this row right here, the third one in the diagram, represents how const is similar to var and final. And then the row down here represents the extra functionality that const has above and beyond what var and final do. Now, before reading all the text on here, let's flip back over to Dartpad, and we're going to get a look at a very quick example of what const can do above and beyond for us. So back over here, I've still got my translator code on the screen. In the last section, when we were talking about the final keyword, I made a really big deal saying that when we used final on the translator variable right here, that only applied to our ability to reassign translator. But we could still freely make changes to this map right here as much as we please. And so that might have been a little bit of a surprise, that we could still modify this map even though we had marked this variable as final. So let's now figure out what const does. What const does on values. Okay, so right before the map, I'm going to add in the keyword const, like so. Now when I make that change, you'll notice that there are no errors appearing inside my code. Clearly, Dartpad has no issue with what's going on right now. But if I click on the Run button up here, you'll very quickly see that I get an error message appearing on the right-hand side of uncaught. So this error message is being thrown because we marked this map right here as const, or constant in nature. When we mark a map as being const, that means we can no longer make any changes to it. All write access to this map has been 100% restricted. And so down here, when we try to add that additional property to the map, we get that error message because the map has now been marked as read-only, or constant in nature. So this is the first added functionality around const. It's what const does above and beyond just being used to declare variables. Now let's kind of rewind here and go back to const when we use it to declare a variable, similar to how we use it for var and final. So I'm going to go back over to Dartpad, and then right above our translator definition, I'm going to make a new variable, and I'm going to define it with the const keyword. So I'll say const read in Spanish. And to this, we're going to assign the string rojo. So now we have defined the string read in Spanish. It contains the string rojo. And I bet you could expect that, yeah, maybe rather than having this duplicate typing of rojo inside of our code base, now rather than using rojo right here, let's try just making a reference to read in Spanish. So I'm going to replace rojo with read in Spanish. When I do so, it looks like everything still works. I don't see any errors or anything like that. Now I'm going to make a very small change. Rather than declaring read in Spanish with a const keyword, I'm going to instead declare it with final. And when I do that, you'll notice that I immediately get a big error message. So this is what the const keyword does for us when we are using it to declare a variable. When we use const to declare a variable, we can then use that variable inside of a data structure that has been marked as const. That's all it does above and beyond what final does. So because I marked this as final, I cannot use it inside of a const definition. If I mark this as const, then I'm back to happiness and I can use it inside of this const data structure. Now, besides just being used to mark a variable as eligible to be used inside of a const data structure, const also locks down reassignment to this variable as well, in exactly the same way as final does. So down here, if I try to reassign red in Spanish with like rojo, or not rojo, let's do something else, let's do like purple, you'll notice I get an error message here as well. And if I hover over it, it says constant variables cannot be assigned a value. So just like with final, when we declare a variable with a const keyword, we can no longer reassign it at any point in the future. All right, so let's summarize. What's going on with const? First off, when we use const to declare a variable, it marks that variable as being ineligible for reassignment in exactly the same way as final does. In addition, a variable marked as constant can be used inside of the definition of a const data structure, like a const map or a const list. The const keyword can also be used to mark a data structure, like a map or a list, as constant, which completely disallows any write access to that data structure. All right, so let's pause right here because I feel like we've gotten to a very good spot. In the next section, we're going to talk about the note that I put right here. So the note says different value types work differently with const. So we'll come back to the next section and clarify what this note means. In the last section, we spoke about the different usages of the const keyword. So const behaves differently depending upon we use it to declare a variable or we use it on a value. At the end of the last section, I had mentioned that different value types work differently with the const keyword. So in this section, we're going to drill down on that a little bit. I'm going to first begin by showing you a diagram of how const behaves on different value types. Okay, so in this diagram, on the left-hand side, we have const being used on an integer or string literal, an object literal, and a class. We'll first begin by talking about what happens when we try to apply the const keyword to a string or integer literal. I want to first make sure that it's really clear what I mean by an integer literal or a string literal. So let's go over to Dartpad very quickly. So over here, I've cleaned up all the code inside of Dartpad and I'm back to just void main. I'm going to try to declare a new variable. I'll give it a name of final my variable. And then I'll say const 1, like so. So 1 right here is an example of an integer literal. The word integer literal refers to us like literally writing out the value of an integer inside of our code. An example of a string literal would be to write out a set of quotes and then any text inside of that. So this right here, string literal. Now you'll notice that in both the case of saying const and then a string literal, and const with an integer, like that right there, we got an error message. So if we hover over this, it's going to tell us expected a type name. So essentially, the issue here is that whenever we declare an integer literal or a string literal, these are already constant values. In other words, the number 1 always means 1, and we cannot change that fact. 1 already is constant. And it's the same with the string of hi. The string hi always means the string hi. It never means something else. So these are already constant values and cannot change. And so we cannot use the const keyword with a const value. Now to be really clear, we can use const on the variable that references a string literal. So if I remove this right here and then instead mark the variable as being const, no issue with that whatsoever. So we are talking explicitly right now about using the const keyword on values. All right, so that is integer literals and string literals with the const keyword. So now we'll move on to object literals, like a literal list and a literal map. We've already been working with a literal map. That's what we saw in the last section. So back over here, if we define a new variable and we point it at a literal map, like hi and there, we get the exact same behavior around const as what we saw in the last video. So this right here is an example of a map literal. In other words, we are literally writing out the contents of the map or the actual structure of the map itself. And the const keyword can be freely used upon this to lock down all modification to the map. So we can also use const keyword on a list literal. A list literal is when we write out a set of square brackets and then directly write our values into this thing. So I can say hi and there inside the list, and now I can make no modification to this list whatsoever. So for example, if I do my variable dot add, which is how we add values to a list, and try to add in some random string, we might not see an error message right away, but if we click on run up here, we'll see an uncaught error appear. And there you go. Okay, so basically object literals like lists and maps work exactly as how we've seen so far. It completely disables any write or any modification to that literal. Now the last thing that we're going to take a look at is using the const keyword on classes. So I'm going to tell you right now that this is going to be a little bit challenging. So I'm going to do my best to explain what's going on with this, and we're going to look at a code snippet. But if it seems like it's really confusing, please don't sweat it, because this is some pretty intense stuff right here. So let's do our best, okay? So I'm going to go back over to Dartpad. I'm going to clean up my main function, and I'm going to declare a new class at the bottom of the file. So I'll say class, let's do translator. I think that works. And then in class, or in the class translator, I'm going to define one variable. I'll say string read in Spanish. So this is something that we've already done several times inside this course already. We have declared classes and associated some instance variables with that class. So now if we were doing things as usual, we could say about final my translator equals new translator. And everything is fine and good to go. Now on my translator, I could freely modify the value of read in Spanish. So I could say my translator.read in Spanish equals Rojo. No issue whatsoever. Let's now try changing up this code just a little bit. I can mark this translator instance right here, or I can create a new instance of the translator, let's put it that way, by using a different keyword than new. So rather than saying new right here, I'm going to say const instead. And now when I do that, you'll notice that it appears there's no change to my code. I don't see any additional error messages, but if I click on run right here, I very quickly see a real nasty error message. So it says constructor is not a const constructor. What this is talking about is, remember, anytime we create a class, we can optionally define a constructor function in the class. So if I define a constructor in the translator, I would write out translator, a set of parentheses, and then a semicolon, like so. Now when I do that, I still see this error message up here. It says the constructor, let's see it, the constructor being called isn't a const constructor. So when we try to create a new instance of a class using the const keyword, Dart wants to see a very special constructor function defined within our class. So we can no longer use this normal constructor right here. Dart wants us to instead define a special constructor that is marked with the const keyword as well. So we put in const translator, as you see right here. And you'll notice that we still have an error message. We'll talk about what that's coming from in just a moment. But now, hopefully you can see that there's kind of a map up between this statement right here and what we have right here. So we're now trying to create an instance of translator that is constant. To create a constant version of translator, we have to call a constant constructor. And that's what we defined right here. Now we again have another error message. If we hover over this one, you'll see that it says can't define a const constructor for a class with non-final fields. So the error message that we see here right now is complaining about the fact that read in Spanish is completely open for modification. In order to have a constant class instance, we have to mark every field on that class as being final. So right in front of this field right here, I'm going to put our final keyword. And this now restricts final, or excuse me, read in Spanish from being modified at any point in time after our instance of translator has been created. If we try to run this code now, we'll again see an error message complaining that we are trying to change a constant value here. So you'll notice that it says set read in Spanish is not a function. Essentially, we are trying to modify a property right here that has been marked as final. So if we wanted to somehow initialize read in Spanish right here, we could add read in Spanish as an argument to our constructor, just as we have previously. So I could say this.read in Spanish. And now anytime we try to create a constant version of our translator class, we would have to pass it in as the initial argument. So I will pass in here Rojo. Now we no longer need to try to assign to that read in Spanish property, so I'll delete that. And we should be able to now run this code and not see any error message. Okay, so there we go. Now the last thing I want to show you, I swear this is the last thing. I told you this class instance const stuff would be kind of nasty. The last thing I want to mention here, this is kind of a interesting property around creating constant classes, is that if we try to create multiple constant instances with these same arguments, we will only ever have exactly one instance created. So let me show you what I mean by that. I'm going to create a second constant instance of translator by writing out final my second translator is const translator, and I'm going to pass in the exact same argument list. So I'll pass in the same argument list. And then after that, I'm going to print out my translator equals my second translator, like so. So because we provided the exact same argument list to each of these constant instances, Dart decides to only create a new instance the first time around. The second time we try to create a new instance, Dart says, hey, you know what? You've already made a constant instance with the same arguments. So I'm just going to return the exact same object in memory that I returned last time. And so if we try to compare absolute equality between these two things right here, and I run this, we're going to see that these two instances are equal to each other. In other words, they are the same record in memory. But if I change the second translator's argument from Rojo to anything else, Dart is now going to say, well, these two things are different. I'm not going to reuse the same instance again. And so if I run this, we get back false because these two things are not the same. Okay, so I know this has been crazy, and I'm sure there might be a very burning question you have. You might be asking, Stephen, why would we ever use a const class? Well, that's a very good question. Let's go back to our code base and take a quick glance at something. I'm going to open up my terminal.dart file. So inside of here, you'll notice that we have absolutely no properties associated with the terminal at all. No properties, none whatsoever. So is there any reason for us to create a new instance of terminal every single time that we try to make use of it? Well, I don't think there really is. I think we could always reuse the same class or the same instance and never try to create a new copy because there's no data tied to terminal whatsoever. So all this const stuff that we've been looking at is very relevant to our terminal class right here because we don't need to make multiple instances of terminal. We can just use one copy and be done with it forever. So with that in mind, let's continue in the next section. We're going to go back to our prompter class, and we're going to instead, rather than making a new terminal inside this file, we're going to mark this as const. And then if we ever try to create a new terminal anywhere else inside of our code base, we're not going to actually create a new instance. We're just going to get back the instance that's already been created. And that's going to save us on having to create multiple records that don't really serve any benefit to our program whatsoever. Okay. I apologize again for the long section. Let's take a pause right here, and we'll come back and work on our prompter class in the next section. In the last section, we had a very long discussion about the behavior of the const keyword. Remember, const is going to behave slightly differently depending upon the type that we are applying it to. So in general, using const on a list or a map is going to behave pretty much as you would expect, but we cannot use it on integer or string literals. And if we try to use it on a class, well, we're going to be in a world for hurt. There's a lot of requirements around that. Now, at the end of the last section, we had mentioned that whenever we create a new terminal inside of our prompter.dart file, there's absolutely no data associated with our terminal class. So if we reused the same instance again and again and again forever inside of our program, no problem with that whatsoever. So inside of prompter.dart right here, rather than creating a new instance with a new keyword, I'm going to create a new instance with const, like so. Now when I do this, you'll notice that we get an error message here that says the constructor being called is not a const constructor. So as soon as we use the const keyword, we do have to define our const constructor. So we'll flip back over to terminal.dart, and at the top of the file, all we have to do is say const terminal, put in our parentheses, and a semicolon, and we're good to go. So now we could go back over to prompter.dart, and everything looks fine. Now, you might be curious, I just want to clarify one thing. You might be curious, you might be saying, hey Stephen, why do we care about avoiding creating multiple instances? We only ever create one instance inside of prompter.dart, and we reuse that instance for all time. Well, remember, that's true of prompter.dart right here, but if we then go over to like some other file inside of our application at some point in the future and try to create a new instance of terminal over there, well, then this would be useful. So as it stands right now, marking this thing as const, not really doing a lot for us, but if we try to create more terminals in the future, then that's going to keep us from creating additional copies of terminal. Okay, so this looks pretty good. Now let's take a quick pause right here and continue in the next section. In the last section, we spoke about what const does to a variety of different types, and I think we've got a pretty good idea of what's going on there. Now in this section, I want to point out some very interesting behavior that's now occurring inside of our application. I'm going to first begin by going over to my main.dart file. And then inside of here, I'm going to do a little bit of code cleanup. So all this prompter stuff down here at the bottom, I'm going to delete. I'm going to leave behind the options declaration, and I'm also going to leave behind this import statement. So these are all going to stay. Then inside of here, we're going to write out some very interesting code. I'm going to write out terminal.print options, and then I'm going to pass in the list of options that we just defined right here, like so. And I'll save the file. Now there's something very important that I want to point out right now. We are getting access to the terminal class right here, or presumably a terminal instance. But you'll notice that we do not have a single import for our terminal.dart file inside of here. So it seems like we are using code that is defined inside of terminal.dart without actually importing it, which seems very interesting. Let's go back over to the terminal and try running this code really quickly. So I'm back inside of my example folder. I'll run dart main.dart, and you'll notice that we get our options printed out successfully. So what's going on? Well, I wanted to remind you about something that we had said back when we first started talking about import statements. When we place an import statement, every single variable, every class, every function, everything that has been defined inside of this file right here is pulled into the scope of this main.dart file. Everything. And so that includes the declaration of this terminal variable right here. So because we define the terminal variable right here, it gets automatically pulled over to our main.dart file when we added that import statement. Now, that might not seem like the worst thing in the world. It might not seem like it's so bad to accidentally import this additional variable over into this main.dart file. But I want to suggest something to you right now. Okay, so I want to make a very quick suggestion. What would happen if we added a function to this file called something like, I don't know, let's call this function don't call me. And inside of here, we did something really crazy like blow up my computer. Only call me if you really know what you are doing. So I'm just going to define that string inside of here. And we call this function don't call me. So let's kind of imagine that you and I might one day write a function like this inside of a library that you and I put together. Maybe it won't be so called, so nasty a name right here, but it might do something inside of our library or have some functionality that we do not want anyone else to call. So I would never want some other engineer making use of the library that you and I are putting together to call this thing. And even I might not want myself to accidentally call this at some point in the future as well. However, since it's defined inside this prompter.dart file, we can freely go back over to main.dart where that file is being imported, and I can call that thing with ease. Don't call me. And so now presumably if I call this function, poof, my entire program or my computer is going to blow up entirely. And so I think it makes a lot of sense to say that there might be variables or there might be functions or classes that we do not want the outside world to have access to. I don't want anyone who's making use of my library right here to really have access to the instance of terminal that we defined inside this file right here. Who knows, there might be unintended effects from that. So in order to restrict access to this variable right here, or to this function, or in theory to this class as well, we can mark certain variables as being what we refer to as private. When we mark something as private, that means that we cannot access that variable outside of our library file or our library folder. So if I mark terminal right here as being private, I can still access this variable within our library, but any consumer of our library, like an example of a consumer is our main.dart file right here, will not have access to that private variable. And that's the exact behavior we would want. We don't want anyone messing directly with don't call me, and we don't want anyone messing directly with the terminal, because that's not the purpose of our library. And if someone calls these functions or references these classes or these variables, they might break how our library behaves, and we don't want that to accidentally happen. So let's figure out how we mark something as private. Well, it's really straightforward. To mark something as private and keep it from being consumed outside of our library, all we have to do is prefix the variable name with an underscore, like so. Same thing with the function name right here. I could prefix it with an underscore. Now you'll notice that as soon as I do that, our code down here turns red. Well, that's easy enough. It's because we've now changed the name of this variable. So I'm going to put an underscore here and an underscore here. And now this file right here is good to go. So I'll save this file. But if I now go back over to main.dart, you'll notice that now I'm getting an error message from these 2 lines of code. You might say, okay, that's totally reasonable, Stephen. Of course, because you just changed the name of terminal and don't call me. But you'll notice that if I put an underscore in front of these now, they still stay in an error state. So simply by putting that prefix of the underscore in front of the variable name, it now no longer gets shared over outside of our lib directory. And again, this is all done for the safety of the code that you and I write. We don't want people messing with functions that are defined on our classes or variables or anything else that we do not otherwise intend them to mess around directly with. So now I can no longer call don't call me, and I can no longer get access to that terminal variable. Now in practice, there are going to be a tremendous number of places that we make use of this idea of making a variable private. And in the vast majority of Flutter documentation, you're going to see that underscore all over the place. So in general, we almost start off by marking methods and classes and variables with that underscore, because usually we might want to assume that the implementation of our libraries is going to be private and should not be exposed to the outside world. So moving forward from this point on throughout this course, we're going to do a lot more thought with every class, every function, every variable that we create as to whether or not we mark it with that underscore. Okay, now the last thing I'm going to do here is delete that don't call me thing, and I think we're good to go. All right, now at this point, we've done a lot of diversions from working on our prompter class right here, so we're going to come back to the next section and really continue working on our prompter. So quick break, and I'll see you in just a minute. In the last couple of sections, we've had some long discussions on final and const and private variables. Now that we've got some additional skills, let's continue working on our prompter class. So at this point, we have successfully attempted to print out our prompt, then print out the list of options, and then inside of here, the last thing we have to do is tell our terminal to wait for the user to enter us a selection. And remember, to do that, we're going to call underscore terminal. That's now the name of our terminal variable. And we want to call the method on there of collect input. That's our method that watches standard in and waits for the user to enter a selection. So I'll call collect input, like so. Now when we call collect input, it's going to return a string, and that string is going to be whatever the user entered. As a quick reminder, if you don't remember what collect input returns, we can always hover over this thing and see that, yep, in fact it returns a string, which is the user's output. So now we're going to take whatever the user gave back to us, and we're going to attempt to look up inside this options list right here what the user entered. So presumably they're going to enter in a number that represents the index of the option that they're trying to select. So I'm going to take this value right here of collect input. I'm going to store it inside of a variable, We'll mark it as final because I do not expect to change this variable at any point, and I'll call it input, like so. Then underneath that, we're going to take this string right here, and we're going to use it to look up an index inside of options. Now, one thing I want to point out is that anytime we try to look up an index inside of a list, we have to provide an integer. But right now, we have a string. So to turn this string that the user just typed into an integer, we can call a method of int.parse and pass in that string. Int is a reference to the global integer class. And as a matter of fact, if you hover over this, you'll notice that it says abstract class int. We'll talk about abstract means later on, but int right here is essentially representing the class. One global function, or one static function as we refer to it, and we'll talk about what that is later as well, on that class is parse. We can pass a string to parse, and the integer class is going to attempt to pull an integer out of that string of input. So now that we've got that value, we can look up the index inside of options and try to pull out the relevant data. I'm going to first begin by removing the semicolon right there. I'm going to put down options, and then we'll look up a particular index using the square bracket notation. Remember that options contains a list of options, and each of those option objects has a label and a value property. Now at this point, from our ask method right here, we could return the entire option that the user selected, but I think it might be a little bit more useful if we just return the value of whatever the user selected. This is definitely up to interpretation. You might think that it's more useful to return the entire option. I don't know, it's up to you. But I'm going to suggest that we return the entire value. And to be honest, I really recommend you do as well, because later on we're going to write some more code that depends upon just returning the value. So after we pull out the specified option, we'll then reference the value property, and we will attempt to return whatever that was. Okay. So this is looking pretty good. I'm going to save this. I'm going to go back over to my main.dart file, and we're going to write a little bit more code inside of here to go back to the state that we had before, where we were creating our prompter and then using it to ask a question. So I'm going to make a final variable called prompter. It's going to be a new instance of prompter, and then we'll do prompter.ask, and we'll pass in that list of options. Oops, forgot the first argument. We have to ask an actual question here. So I'm going to ask, what color do you like? Cool, so that looks good. When we call ask, it's going to return whatever data value we had provided to the selected option. So I'm going to take that data value and I'm going to put it in a new variable. Let's just call it something like users pick. I don't know, whatever you want to call it. And then we'll print that out, users pick. Okay, time to test this. I'm going to flip back over to my terminal. I'm going to get into my example directory, and we'll do dart main.dart. All right, here we go. Here's the moment of truth. So I'm going to say that I want red, so we'll enter in 0, and I get a return, or a print statement right here of £F00, which you'll recall is the hex code for red. Awesome. So that's pretty much it. It's working. We got the entire flow. And there's still some polish that we really need to add on here, but I think you got an idea of how this thing's going to work now. So let's take a quick pause right here. We're going to come back to the next section, and I do want to point out a couple locations that are kind of awkward about the code that we've written so far. So quick break, and I'll see you in just a minute. In the last section, we did a full end-to-end test of our program after doing a little bit more work on our ask method. We then tested it out at the terminal, and everything appeared to work a-okay. But there's one little thing I want to point out to you. If we go back over to our terminal and try running this test one more time, I'm going to try entering in a number that is not on this list right here. So I'll put in 2. And when I do that, boy, we get a nasty error message. I can also try testing it again, and I will not enter in a number at all. So let's put in a bunch of random characters. And that gives us a really bad error message as well. So clearly, I think we need a little bit better error handling than what we have right now. So I'm going to show you a very easy way to address this issue. And this is a way that probably matches up how someone using our library would expect this ask method to work. So we're going to say that if this line of code right here, which tries to get an integer out of that output, or the input, excuse me, it tries to get an integer out of our input, if this line of code throws an error, we're just going to run the ask method again and essentially tell the user of our application, hey, you just entered an invalid input, try again, please. So in order to watch for this line of code right here to throw an error, we're going to wrap it with a try-catch statement. Let's write out the code for it and we'll talk about what it does. So right here, I'll put try, a curly brace. I'll then indent the return. I'll put on a closing curly brace, and I'll say catch error, and then another set of curly braces. This is a try-catch statement, and it works very similar to how it works with JavaScript if you've ever used it over there, and try-catch statements in a variety of other languages as well. What happens is we run the body of the try statement. If any error is ever thrown by this code right here, then the try execution immediately stops and execution goes down to the catch block instead. So catch essentially means catch any error that occurred. And so this would be a great location for us to attempt to re-ask the question and give the user another chance to actually do the right thing or enter the right text, so to speak. So inside of here, we can recursively call ask again. So I'll say ask, we'll again pass in the prompt that we got, and then pass in the options that we got. We make no modification, we're just going to pass this stuff straight through. When we call ask right here, we do need to make sure that if this attempt to call ask does yield a usable value, we return it from our overall function call. So I'm going to put a return on here as well. Okay, so let's save this and we'll try it out again. So I'll go back over. I'm going to start up dart main.dart, and now if I enter in some random stuff, it tries to get me to answer again. And it repeats on and on and on. If I finally enter in a valid input, then I still get back a return of pound F00. Okay, so that looks pretty good. We definitely have some better error handling at this point. Now let's continue in the next section, and there's just one or two little things I want to add into this project. We're pretty far along on our prompter library. We're almost done with it, but there's one last thing that I want to remind you about. When we first got started with this project, we looked at a series of mockups like this one right here. So in this mockup, we had said, what color should we use? And then prompted the user with a multiple choice selection. We also looked at this diagram, which was also a multiple choice question. But then we also looked at one third mockup, this one over here. So this was a very different type of question. It was a yes/no type of question. Right now, we don't really have the ability inside of our current prompting library to implement this thing, or at least get something like this to show up. Now, of course, we could kind of like cheat our way out of this, and we could use this multiple choice UI right here to implement it. In other words, we could make one option that says, yes, and another one that says no, but, come on, that's kind of lame. I think we could do better. Really, I want to be able to ask the user a yes/no question and allow them to enter Y or N and have that be it. So in this section, we're going to start working on the implementation of this other type of question. I'm going to first get started by flipping back over to my code editor, and I'm still inside of my prompter file. Now inside of here, we currently have one method, and it's called ask. This method at this point is clearly concerned with asking our user a multiple choice question. Everything about this function is all about handling a list of options and then parsing the input that comes back from the user and returning the correct option. So rather than calling this thing ask right here, I'm going to rename this function, and I'm going to instead call it ask multiple, because that's going to make it really clear to people who are using our library that this is going to help you ask a multiple choice question. Now remember, we also have to update this function definition right here, or the invocation, excuse me. So I'll update that to ask multiple as well. Then right above this, I'm going to make a new function that's going to be responsible for asking yes/no questions. So up here, I'm going to make a new function, and I'm going to call it ask binary. Now I'm calling it binary because you either answer yes or no. It's like a binary choice, yes or no. No other choices whatsoever. That's why we're calling it binary. There's nothing like binary data type or anything like that about this. So in the choice of a binary question, there are no options associated with it. The only two options are yes or no. And so in this case, I don't think that we really have to receive a list of options. I think all we have to do is receive a prompt that will be displayed on the screen to the user. So I will receive a string argument of prompt, and that's it. Then inside of here, we'll start off by printing out that prompt on the screen. So I'll do something like, how about we'll access that terminal, we'll call print prompt, and we'll pass in the prompt that needs to be printed. Now, if you remember back over here, we showed at the end of the question the kind of YN to make sure that it was really clear what type of feedback we expected to receive from our user. I think that maybe we will make sure the YN always shows up automatically. So what we could do is say when we pass in print prompt right here, which is a string, maybe we will kind of do some string interpolation right here. We'll put this into a string itself. We'll use our $sign to reference that variable, and then we'll put in that YN like so. So now anytime someone calls ask binary, they do not have to manually add in that YN designation. They can just add in the prompt that they want to ask. Okay, so let's take a quick pause right here, and we're going to continue working on our ask binary implementation in the next section. In the last section, we put together our ask binary method. At present, we are just prompting the user with some question and then presenting the string YN. So we need to then make sure that the user has the ability to enter some text. To watch our terminal, we're again going to use the terminal collect input method. So underneath that, we'll say final input terminal.collect input, like so. So just like before, input is going to be whatever the user just typed in. So it's going to be up to us to inspect this string right here and decide whether or not the user entered Y or N. To make things easy, I think that we'll make a little bit of an assumption here. We'll say that if the user enters any text that has Y in it, then they probably were trying to answer yes. So if they enter like yes, like so, that's going to count as an affirmative to this question right here. If they do something like that with a Y, you know what? We're still going to call it a yes. So all we really have to do is look at the string that the user returned to us and check to see if there's a Y character inside of it. To do so, we can use a built-in function on every string. I'm going to pull up the Dart core library documentation over here. So again, I'm at api.dartlang.org. On the right-hand side, I'm going to scroll down to find the documentation for the string class. Here it is right here. So one method that every string has is a method called contains. So we'll scroll down a little bit. We'll go down to our methods section. There we go. And in here, I'm going to find contains. So we can use this contains method to see if a string contains a certain character. So essentially, all we really got to do is look at that input variable and look to see if it contains a Y character. So let's try it out. Back over here, I'm going to return input.contains Y, like so. So now someone can ask a binary question. We'll display their prompt on the screen. We'll wait for some input. And then if that input contains a Y, then we'll say, yep, that contains a Y. They answered affirmative. So unlike ask multiple down here, where we returned an option, in this case, we're going to return a Boolean that says, yes, true, they answered truthy, or false, they answered falsy. To make sure that that's really clear, let's make sure that we mark this function right here as returning a Boolean. If you hover over ask binary right now, you might notice that it's currently thinking that it returns dynamic, which is not the case. It's always going to be returning a Boolean. So I'll mark this as bool, like so. Okay, I think we're ready for a test. So I'm going to flip back over to our main.dart file. Then inside of here, I'm going to clean up those last two lines of code. And we'll call prompter.askBinary. And we'll ask about, do you like Dart? Sure, that works. I'll save this. And you know what? Let's make sure that we log out whatever the user enters here. So we'll do a print statement on the results of that. Okay, so let's go test this. I'm back over at my terminal. We'll do dart main.dart. And then we get asked, do you like dart yn? Now, I'm looking at this right here, and I'm noticing that there's something very different than what was happening with our ask multiple. With ask binary, we did not correctly clear the terminal. And with ask binary, we are also not properly showing that little caret that indicates that we're waiting for the user to enter something. So, okay, maybe we're on the right path here, but clearly there's a little bit of polish we need to add in. Now I'll try entering in a y and hitting enter, and we do see true. If I do the same thing again and hit n, we get false. So at least that appears to be working. But clearly we do need to at least attempt to clear the screen, and we need to try to print out that caret there as well. So let's continue in the next section, and we're going to take care of those two pieces of polish. In the last section, we tested out that test binary stuff, and we noticed that there was a little bit of a need for some polish inside there. So at present, we did not successfully clear the terminal before we asked a question, and we also didn't show a caret next to where the user should be entering some text. Now, while we're at it, I also very quickly went back and tested out the test ask multiple method, and I noticed that we were not actually clearing out the terminal in that case either. So I think that we need to do some work on both ask multiple and ask binary. So I'm going to flip back over to my code editor, and we'll first take care of the fact that we are not successfully clearing out the terminal before we ask any question. So right above my print prompt inside of ask binary, I'll call terminal.clearScreen, like so. And I'll make sure that I do the same thing inside of ask multiple at the top as well. So terminal clear screen. So now in both cases, we are successfully attempting to clear the screen before we print any information. So now we can focus back on our ask binary method again, where we need to make sure that we print out that little caret that designates a y or an n. Now I want to remind you something interesting. We've actually already hooked up our terminal.dart file right here with that print options method. So print options prompts the user to enter a choice, and then it writes out that little caret character. So these two lines of code right here are essentially exactly what we need to have happen inside of ask binary. The only issue is that we had called this thing print options, right? And if we want to call it print options, we have to pass in a list of options. So it might seem like we can't really make use of this. But you know what? Maybe we can. Here's one option. I want to show you something. It's going to look strange. You might think, Steven, this is a bad approach. Don't do this. But I want to show it to you. And then once we add in this little line of code, you're going to notice something else very interesting about our prompter class. So rather than trying to get our terminal to print out that caret character just by itself and not reuse that print options method, we're going to call terminal.printOptions, and we're going to just pass in an empty list, like so. So empty list, print options is happy because it got an empty list. Back inside of our terminal file, we're going to take that empty list, we're going to try to iterate through every element inside of it, but that thing's empty, so we're not going to print out anything at all. So all print options is going to print out is enter a choice and that caret, which is exactly what we wanted. So let's very quickly test this out. And then after we do that, I'm going to point out something very interesting to you. So real quickly, I'm going to go back over to main.dart. I replaced the ask multiple here for the ask binary with a quick test just to verify multiple was still going. So I'm going to flip back here really quickly to ask binary. Okay, that looks good. There we go. So now we'll do another quick test. And when I do that, okay, much better. So we cleared the screen, we've got enter a choice, and we see that little caret. It's really obvious that the user is supposed to enter something here. Okay, so that definitely works. But now I want to point out something very interesting to you. I want you to look at the source code for ask binary and the source code for ask multiple. So in both these functions, we first start off by calling clear screen. We then call print prompt with essentially the same thing. And then in both cases, we call print options with a little small difference. But in total, really these two functions are starting to look very, very similar. So here's a crazy idea I have. I think that rather than duplicating all this logic right here of calling these same functions over and over again, maybe we should make one central method, like one method to actually ask a question or actually make use of this terminal thing. And then everything else around asking a binary question or asking a multiple question should be left inside of the respective asking question method. Now that might sound complicated, but let's take a quick pause right here. We're going to come back in the next section and we're going to start working at kind of consolidating a lot of this common logic into one single method. So quick break and I'll see you in just a minute. In the last section, we spoke about how ask binary and ask multiple had a lot of very similar code inside of it. And so in this section, we're going to introduce a new function to our prompter class. And this new function is going to be like the central point of interacting with our terminal and getting some information out to the terminal. So I'm going to go back down to the bottom of this class, and then while still inside the class, I'm going to add on a new method that I will call simply ask. So this is going to be the common point of interacting with that terminal, and all this repetitive logic that we just put into ask binary and ask multiple is going to go into that new ask method. So inside of here, we need to first figure out the arguments that we expect this thing to be called with. Well, if this is going to be responsible for passing off information to the terminal, then I think it definitely needs to know about what the prompt is, and I think it also needs to know about the possible list of options. So I'll say list, option, and options. Of course, in the case of ask binary, we don't have any options, but remember, we can kind of get around that by just passing in an empty list like that right there. So now inside of here, we can place all the common logic between both of our ask multiple and ask binary. So we're going to first call terminal.clearScreen, because both those functions want to clear the screen. We'll then call print prompt and pass in our prompt, and then we'll also print out our options. So print options with options. Then after that's all done, we'll wait on the terminal to solicit some input from our user. And we can do that by calling terminal.collectInput, like so. Now when we get back this input, it gives us some value that's presumably going to be we're going to want to use that elsewhere inside this class. So I'm going to call return on this thing. And since we now know that we're going to be returning a string, because that's what collect input right here returns, I'm going to make sure that I mark ask as returning a string as well. Okay, so we've now created this new ask method and put a lot of common logic between both ask multiple and ask binary inside of it. So now we can refactor both these methods and subtract all that common logic and replace it with a single call to ask. So now inside of ask multiple, I'm going to delete all this stuff right here, and then we'll simply call ask and pass in our prompt and the list of options. Or excuse me, not ask, prompt, there we go, in our list of options. And then remember, when we call ask, that's also going to wait on the terminal to provide some input back to us. And so we'll make sure that we take whatever comes back, and I'll assign it to a variable that I'll call input, because that's what we were actually using right here on this line. So now ask multiple is at the same exact point that it was before, totally usable. Now we're going to go back up to ask binary and do the same refactor. So up here, I'm going to find all that common logic. I'm going to delete all of it, and then we will replace it with simply ask. So in this case, prompt is a little bit more confusing. So we get the prompt right here, and we're going to pass it in. But remember, we also want to present that kind of y/n at the end of the prompt as well. So we're still going to put this thing into a string. We're going to put our $sign in, and we'll make sure that we print yn on there as well. And then as a second argument, we're going to pass in an empty list to kind of fill out ask's requirement of receiving a list of options. So right here, I'll do an empty list. And then of course, when we call ask, it's going to eventually return whatever the user entered into the terminal. So we will again assign that to a variable that we'll call input, like so. Okay, well, I don't know about you, but that looks like a solid refactor. So we just took a bunch of code that was common to both ask binary and ask multiple, and we extracted it to this new common use function right here. Now, one thing I want to make sure is really clear, you might be curious, Stephen, we had ask before, why are we back to having ask again now? Well, ask is more of kind of like a general point of taking some information and then just returning whatever the user put in. So ask multiple and ask binary still have custom logic inside of them to interpret what the user entered. So there's still a lot of reason to keep around ask binary and ask multiple. There's really not a lot of reason to keep around ask or make ask publicly exposed. Well, let's talk about what I mean by that. We'll take a quick break and we'll come back to the next section, and I want to point out something about ask as it currently exists. In the last section, we implemented our ask function, which was a great refactor that removed a lot of duplicate code out of ask binary and ask multiple. Now, before we move on, there's one quick thing I want to point out about this ask function. If we go back over to our main.dart file, you'll recall that we created a new instance of prompter right here. So I'm going to put a new line right underneath that. And I'm just going to write out prompter and a dot, and I'm just going to pause for 1 second. So I want you to imagine for just one moment that you and I take our library right here, our prompting library, and we distribute it to the world. And maybe our package is really popular, and tons of people download it, and they install it, they read the documentation that says, yeah, create a new instance of prompter, and then you could start asking questions. And they get like that far. They read the documentation to the point that it says, create a new instance of the prompter class. So then they read that far, They do that, and they go, okay, well, I guess I want to use this prompter thing. And they stop reading the documentation because they're going to assume they know exactly what they're doing. So they go, all right, let's see what this prompter thing has. I'm going to write out prompter dot, and okay, it has methods ask, ask binary, multiple. And you know what's going to happen? The user of your library is going to look at this thing, and they're going to say, oh, ask. Well, that sounds like a function I want to use because I installed this library to ask a question at the terminal. So here's what they're going to do. They're going to say, yeah, that's the function I want. I want to ask a question. Then they're going to say, oh, prompt, sure, I can figure this out. They'll enter a prompt, and then they'll do some options, and off to the races they go. Now, there's just one issue with this entire situation as I just laid out. When a user calls ask right here, there's no validation, no error handling, nothing like that is being done whenever this ask function is being called. All ask does is throw some information onto the screen and then return the direct input from the terminal. There's no error handling, like this try catch statement right here, and there's no good support for ask binary, like you see right here. So I'm going to make the claim. I'm going to say that if you and I distributed this library to a bunch of users, we very likely would prefer them not to directly call this ask function. We don't want them to even know it exists. It's very generically named. They might fall into using it, and if they use it, they're going to end up with a suboptimal experience because they don't get the benefit of all this extra code that you and I put together inside of ask binary and ask multiple. So in short, what you and I really want to do here is make sure that this function exists but is not visible to the outside world. So in other words, we want to make this function private. Remember how we make something private. All we do is put an underscore in front of its name. That's it. So now, and there's some errors now inside this file, we'll come back and tackle them in just a second, but now if we go back over here and we imagine that same exact user goes and installs our library and then reads the documentation and gets up to the point where it says, yeah, create a new instance of prompter, and then they go, okay, I can figure this out from here. I'll do prompter dot, and now you'll notice the only functions that are available are ask binary and ask multiple. And these are the two functions that we want our users to call. We don't want them to directly call that ask function, and that's why we just marked it as private. So now we can call ask binary. We can enter in whatever prompt we want, and off to the races our users go. And they have a great time because ask binary handles input from the direct user of like whoever's at the command line. It handles that input correctly. Okay, so hopefully now I've kind of, again, like we spoke about private previously, but hopefully now again I've kind of made a reasonable case of why we care about private variables and private functions. So when we last spoke about private, I had said that, oh yeah, we can mark variables as private that are defined inside of a file. And same thing with functions, same thing with classes. We can also do the same thing with methods on a class as well. So if we want to make sure that someone does not directly call a method on a class, you put the underscore in front of it, and now no one actually sees it. Okay, so that looks good. Now the last thing I want to do inside of here, we did put that underscore on here, so we need to repair some of the references inside this file. So inside of ask binary, I'll make sure I update that with the underscore. And ask multiple, I will do the same. Okay, so now I think that we're in a much better state. So let's continue the next section. And the last thing we have to do here is kind of put together a fully complete example that can be used as a demo for our users. So quick break, and I'll see you in just a minute. Our project is almost complete, but there's just one or two quick things left for us to do. So in this section, we're going to kind of do a throwback to something we spoke about way earlier as we started working on this project. You'll remember that we spoke a little bit about our general folder and file structure inside of here. So I'm going to open up a diagram that we looked at previously. Now I've updated this diagram to reflect some of the different files that we currently have inside of our SRC directory. So at present, our main.dart file inside the example directory is directly importing, I think, our terminal, no, our prompter, and our option class as well. So we've got those two direct imports at present. Now in general, we really prefer that outside users of our library, and remember this example main.dart file is intended to be like a very real example of how to consume the library. We really don't like people poking directly inside the SRC folder. When people start looking directly inside this thing, they might get it into their head that they should have access to different things that you and I have put together inside of here that we really don't want them to get access to. So this is a very similar discussion to what we just spoke about with all that private stuff. So when people start going directly into the SRC directory, that means that our code or our library might not work the way we expect. So we really want to make sure that users or consumers of our code get this kind of very well-scoped API, and they just see the different classes and functions and variables that we want them to see and absolutely nothing else. So to accomplish that, we usually create a single file inside the lib directory. We usually name it with the same name as whatever our library is called. And then here's what happens. We import all of the code that we want to expose to the outside world. Like for us, it's our prompter file and our option file. So we want both those classes to be exposed to the outside world. So we will import them into this file, and then we will immediately turn around and export that code from this file as well. And then main.dart can import stuff from prompter sg.dart. And we don't have to worry about some consumer of our library diving into the src folder. So again, you can kind of think of this file right here as being kind of like the central interface point for everything that we've defined or everything we've put together inside of our library. So let's take a quick break. We'll come back in the next section, and we're going to put this kind of central interface file together. In the last section, we spoke about how we really don't like people going directly into our src directory and trying to retrieve code out of there. Instead, we like to create a file directly inside the lib directory. We usually name that file after our library, and then we import the files we care about or the files that we want to share with the outside world into that file. And then people who are consuming our library will import that file alone and nothing else. So let's flip over our code editor, and we're going to hook all this stuff up inside of our project. So back inside my editor, I'll find my lib directory, and then inside there, I'm going to make a new file that is named exactly after my package. So my package is called prompter_sg.dart. And as a quick reminder, your package name is reflected inside of the, pubspec.yaml file. So your name of your package is this right here. Okay, so now inside of here, we're going to import and immediately export all the different files that we want to share with the outside world. To do so, all we have to do is write export and then the name of the file that we want to share. So in our case, we want to make sure that our option class is accessible to everyone in the world and our prompter class is accessible to everyone in the world. So I will write out export, and then we're going to walk into the src directory, and then we will specify the option.dart file. So src/option.dart. And then we'll do the same thing for our prompter.dart file as well. So you can view these export statements right here kind of being like a pass-through of sorts. If anyone requires or imports this prompter sg.dart file, they are going to kind of receive or actually import all the code that was defined inside of these two files. So again, we're kind of combining multiple import statements and throwing them all out at once. So now we can go back over to our main.dart file, and rather than reaching directly into the src folder, we're going to only import that file that we just created. So I'm going to delete one of our import statements, and then after package:/prompter_sg/, I'm going to specify the file we just created. So it's going to be prompter_sg, which is the name of my package, and then prompter_sg.dart, which is the file that we just created. Okay, and that's pretty much it. So we can now save this file, and we should still be able to run this project and have everything be a-okay, but now people are only importing the code that is relevant to them, and they're not going to be trying to pull in code that they should not be touching at all, like, for example, the terminal class. Okay, so this looks pretty great. Now the last thing we need to do is polish up our example right here, and then we'll be ready to publish this thing. So let's get to it. One of the last things we have to do inside of our package from a code standpoint is to polish up our example file. So inside of our example file, we want to make sure it's really obvious exactly how you use our library. So we're just going to do a quick example of calling the askMultiple function and the askBinary question. I'm going to first get started by removing the code that we had here for the two askBinaries. And then underneath where we create our prompter instance, I will attempt to call askMultiple. And I'm going to, again, ask the user to select a given color. So we'll say prompter.askMultiple will provide a prompt of select a color, and then we will pass in our list of options. Now, of course, we want to make sure it's really clear that askMultiple right here is going to return whatever data property was passed into the option. So as a return value, I'm going to create a new variable. I'll call it color code, and it's going to receive whatever comes back from askMultiple. And so hopefully in this case, it's going to be at least somewhat clear to people who are reading this example file that color code is going to contain the relevant color code that was picked up here. So then underneath this, we'll also do a quick example of using the askBinary function. I'm going to give myself a little bit of space just so we can see the whole line. And then we'll do, we'll do prompter.askBinary. How about we ask, do you like this lib? I don't know, maybe they do, maybe they don't. Whatever. And we'll make sure that we indicate that askBinary returns a Boolean, by creating a new Boolean value. So I'll call this variable answer, and then maybe after asking both those questions, we can print out color code and answer. So now hopefully it's going to be at least somewhat clear to our users exactly what's going on here. And oops, I made a little mistake. Print only takes one argument, so we're actually going to call print twice. We'll do color code and print answer. Okay, that's better. So now hopefully it's a little obvious to our users who want to use our library. They can read this file and get a better idea of how to interact with it. So last thing we're going to do is a quick test of this on our own over at the terminal. So back inside the example directory, we'll do dart main.dart. And then I'll first select red, and then do I like this lib? Yes. And then we get out that nice print statement of the color that was picked and true to indicate that I entered yes. Okay, so that's pretty much it. That is it for our project as far as actually writing code. Now we are going to actually deploy this project as a downloadable or installable dependency, because you and I are actually going to use our prompting library on the next project we work on. So let's take a quick break. We're going to come back to the next section, and we're going to figure out exactly how we deploy this thing and make it available for the outside world to download. So quick break, and I'll see you in just a minute. Our project is now in a pretty good spot, and we're ready to push it up to some central repository where other engineers will be able to clone our project and make use of it on their own personal projects as well. So here's how that's going to happen. On the left-hand side, we have our project. We're going to publish our project to a website called DartPub. DartPub is this central repository that I was talking about. It's a website and a service that allows us to share our Dart code with other engineers. You can access DartPub by navigating to pub.dartlang.org inside of your browser. And then once here, you can take a look at a bunch of different packages that you can freely make use of and install on your own Dart projects. So you and I are going to be adding our own project that we just put together to this repository. To do so, we're going to take a look at that pubspec.yaml file that we put together a little bit ago. Remember, this is the central configuration point for our entire project. When we try to publish our project to DartPub, all the details and configuration that we entered into that pubspec.yaml file will be made use of. So back inside my code editor, I'm going to pull that pubspec.yaml file back open. Now inside of here, at present, we only have a project name, a version, and a description, and nothing else inside of here. So it turns out that if you want to publish your code or publish your project up to pub, you have to have a couple of other pieces of configuration inside of here. Now we're not going to guess on these other pieces of configuration. Instead, we're going to make use of a tool that's going to tell us exactly what we have to do to get our project ready to be pushed up to pub. So to use this tool that's going to help us finish off some configuration inside of here, I'm going to flip back over to my terminal, where I'm still inside of my project directory. So if I list out my files and folders inside of here, I should see that pubspec.yaml file. Then inside of here, we're going to run the command pub publish -n. The -n flag on here essentially is telling pub that we want to attempt to publish our package to pub, that central repository, but we only want to do a dry run. Or in other words, we want to be told if there's any issues with the project that we've currently put together. And we want to be told how we can resolve those issues. So I'll run this command, and then we'll get a big block of text here. You'll notice that one of the items says missing requirements. So these 4 starred items right here are all the things that you and I have to do to get our project into a state where we can safely push it up to pub. If we don't do these things, then we're not going to be allowed to push our project up. So let's take a quick pause right here. We'll come back in the next section, and we'll talk about how we're going to accomplish each of these items. In the last section, we ran a command that told us all the different things we have to do before we will be allowed to push our project up to pub. So in this section, we're going to go through our project and fix all 4 of these items. The first thing we have to do is to create a license file inside of our root project directory. This file is going to contain some legal information that grants access to other engineers to legally use our code on their own personal projects. So let's take care of that right now. Back inside my code editor, I'm going to create a new file inside of my root project directory called license. I'm going to use all capitals, and I do not need an extension on here. Then inside this file, I'll simply write out MIT license. Now this right here, this is not code, it's not markup, nothing like that. This is saying that our project follows the MIT license, which allows other engineers to freely get access to our code with no obligation to them, no obligation to us. So it's just saying freely, this is an open source package, do with it what you will. Okay, so that's all we have to do for step 1. We're now going to move on to step 2. For this one, we have to add an author field to our pubspec.yaml file. This author field is going to contain our contact information, and it's just going to allow people to know exactly who we are and who made this package that they're trying to use. So back inside my pubspec.yaml file, I'm going to add on an author field, oops, lowercase, and I'll put down my name, and then inside of a less than sign, greater than sign, I'll put down my email as well. Okay, so that's step number 2. Now step number 3, we have to add a homepage field to our pubspec.yaml file as well. The homepage field is supposed to be the source of documentation, or essentially the homepage of our project. Now you and I do not have a homepage for this project or anything like that. So for my homepage, I'll put down, how about https www.google.com. So just some dummy website because, again, we don't have a homepage for our project. And then finally, the last item we have to do is we have to specify the environment SDK versions, or more specifically, something called an upper bound constraint. So the idea here is that you and I are going to publish this package to pub, and it's going to sit around on this dependency tracking website for some number of years. And in those years, Dart might get some newer versions. Right now we are on Dart version 2, but let's say in 10 years, Dart version 10 comes out. Well, chances are that some of the code that you and I just wrote inside this project might not work out so well with Dart version 10. And so we would not want people to accidentally install this package if they're using a much newer version of Dart. So the idea behind this item right here is that we're going to say that if you're running anything greater than some particular version of Dart, you are not allowed to use this package because chances are our code is not going to work out too well. So for this, we're going to flip back over one more time to our pubspec.yaml file. I'm going to add on environment. I'll give it a key of SDK. And then inside of a string, I'm going to put less than 3.0.0. So this essentially says that you can only use our project if you are using a version of Dart less than version 3. So version 1, version 2, you're good to go. But if you start going up to version 3, 4, 5, or whatever, sorry, chances are this code's not going to work, and we don't want you to install it. Now, one quick thing I want to point out here, because the spelling is very tricky, take a look at the word environment right here. Notice how there is an N inside here. So really tricky word if English is not your primary language, and even if it is, very easy word to misspell. So double check your spelling on environment right there. Okay, so then I'll save this file one more time. I'll go back over to my terminal, and I'll try running pub publish-n again. And now when I do so, I see that my package now has 0 warnings, which means we are now ready to push it up to pub. So to actually push this up and to publish our package, we will run the command pub publish. And we'll be asked to confirm that we want to do our upload. I'll say yes. And that's pretty much it. So now we can flip back over to our browser and try to look up our package on pub. If you flip back over to your browser and navigate to pub.dartlang.org, you can try to search for your package name right here. So your package name is going to be whatever name you entered into your pubspec.yaml file. So for me, I could do a search for prompter_sg. So I can search for that, and then I can see the version that I just uploaded right here. Now, one thing I want to mention, if you just uploaded your package like 2 seconds ago, you may not see yours come up here just yet. In my experience, it takes like an hour or so sometimes for me to be able to search for a package and actually find it listed on here. So if you don't see yours popping up just yet, that's totally fine. Just give it a little bit of time and then try it again. Okay, so this looks pretty good. I think that our project is now published, which means we can now start a new project and install the prompting library that we just put together. So quick break, and we'll kick that off in the next section.